Well, hello, Internet. You guys are always asking me questions about how to analyze the stock market using Python. So I'm going to create a new series, and it is called Python for Finance. And in this first video, we're going to have a rundown of NumPy, Pandas, Matplotlib, Matplotlib Finance. I'm going to show you how to download stock data, how to save that stock data, how to use mask to grab blocks of that data, how to merge stock data into another data frame, how to plot it, how to style those plots, and then we're going to get into analyzing returns, plotting multiple returns in one plot. We are also going to talk about variance, standard deviation, coefficient of variation, and numerous other things. More videos are coming, and I have a lot to do, so let's get into it. All right, so here you can see every single thing that's going to be covered. And I'm using Jupyter here. If you want to know how to install it, in the description, I have a link that shows you how to install it on the different operating systems. But what we're going to be covering here is I'm going to show you everything you need to import. I'm going to show you how to save stock data from the internet into comma-separated value files. I'm going to then show you how to get that comma-separated value file converted into a data frame. We're going to be able to calculate daily returns, total returns over a defined time period. You're also going to be able to define time periods for downloading the data also. We're going to be exploring Matplotlib Finance, which provides a lot of tools. I'm going to show you how to create a very simple price plot, which is very important if you want to be able to create more complicated ones. I'm going to show you how to download multiple stocks at once, how to merge multiple stocks data values depending upon a column name. We're also going to plot out and get changing values of an investment from multiple different stocks, so we can do more complicated things like that. We're also going to explore standard deviation, which I'll explain here in a bit, and a whole bunch of other different things as they come about. A lot. All right. So what do we need to import here first? Now, I have a complete data science course with all the links in the description, so where I cover everything in massive detail. We are going to need NumPy. Let me zoom in here so that you can see this better. All right, so we're going to need to import NumPy, and I just went full screen here so you can see everything really good. And what it does is, to make it extremely simple, is it just provides ways to work with large multi-dimensional arrays of data. And we are going to abbreviate this as NP. I'm also going to need pandas, and what it's going to allow us to do is further add capabilities to what NumPy provides, and it's going to allow for further data manipulation as well as analysis, and I'll abbreviate that with PD. We are also going to need to be able to read stock data from the internet and download it and save it on our computer. And for that, we're going to go and get pandas, data, reader, and say import data as web. And we're also going to be using Matplotlib and PyPlot specifically for plotting out this information, and I'll abbreviate that as PLT. We are also going to be working with styling of dates, and I'm going to need matplotlib.dates, and I'm going to call this as mdates just to abbreviate it. And we also have to put this setting inside of here so that everything displays properly. So matplotlib in align. And we also are going to need date time, and I'll abbreviate that as DT. And that's going to allow us to define dates for which we want to manipulate data, as well as for being able to go and ask for specific ranges of data. What am I doing here? Matplotlib Finance also, and I'm going to abbreviate that MPF. All right, and that's everything. So you need all of those different things. So what I want to do here first is I want to go and create a function. Whoops, what'd I do? I spelled something wrong. Whoop, I actually know what this is. I don't have Pandas Data Reader installed on this, so it's actually a good thing that that came up. And to fix this problem, what you're going to do is click on Environments in Anaconda Navigator over here. You're going to check Not Installed, and then you're going to type in pandas-data reader like that. Just select it like this, and then come down here to the lower right-hand corner and click on Apply. And it's going to download that for you. And that's how you install all the different packages that you may need in the future. This is going to pop up, and you're just going to type in Apply after this. I normally use my Windows computer to do all this stuff, but whatever. That's a good thing that came up, because now you know how to solve it. All right, so it's installed. And now if we go and run our code, you can see that there are no problems. All right, so good stuff. All right, so now back to creating our function that's going to save stock data to a CSV file. I'm going to go and create this function by going def and save to CSV from, and I'm going to be using Yahoo to Finance to get all this information. It's free to use. And what we're going to do is we're going to pass in the ticker that we want. We're going to have the starting year that we want to grab data for, the starting month, and the starting day, the year in which we want to end pulling data, and month and day as well. So that is all that information. Put in a colon there. Now what I want to do is define the time periods that I want to use. I'm going to call the first part start, and then you say DT and date time. And I'm just going to pass in starting year that the user requested, the starting month, and the starting day. And I'm going to do basically the same exact thing for end. So I'm just going to copy this, paste that right there, and change this to end. And then pop this in here, and this will be the end, like that, and like that. All right, good stuff. Now I want to actually go, and I'm going to call this DF because it stands for data frame. And I want to read all of the data using our defined information here. So I just say web dot and data reader. There, remember that? We just downloaded it. And to get this information, all I have to do is pass the stock ticker. I'm going to say that I want to grab information from Yahoo and start and end. There we are. We have our data frame with all of our data. Now I want to go and I want to save to a CSV file from this data frame. And then you're going to define exactly where you want to save all of your information. And then at the end of this, what I'm going to do is I'm going to put a / and then a plus sign and the ticker that they passed inside of it. And then I want to end that with .csv, right like that. And then on top of that, I am going to go and return this data frame. And we can go and hold down Shift and return. And I'm going to come down here and I'm going to test this. So let's come down into test functions. Actually, I might as well come up here and just copy this so I don't have to type it again. So copy that, come down into test functions, paste that inside of there. And to start off, let's say I want to get information on Amazon. So I'm going to say Amazon like that. And let's say I want to get everything from 2020, from the beginning of January through 2021. And again, from the beginning of January. We can execute that. And you can see here is all of the information we were able to download. So works. So good stuff. Now what I want to do is go and be able to retrieve data from that same CSV file. And I'm going to do this and create custom functions for everything. So it'll be really easy to work with this stuff. So again, I'm going to go and create a function. And I'm going to call this get data frame from CSV, and all I need is the ticker because I have the file name is the ticker, and I want to go and put this inside of a try block. So I'm going to go and try and get this file, and if it doesn't exist, I'm just going to issue a warning on the screen. So I'm going to go data frame is equal to and pandas and we use a function called read CSV, and we're going to be reading it from the same place we saved it. So let's just come in and grab all of this information and copy it, and come down here and paste it inside of there. So that's where I'm saving all of my stock data. Now what we can do is come down and handle any type of issue we would have. And the exception that will be thrown is file not found error. So that means the ticker's wrong, we don't have the file or something. All right, and in that situation, I'm just going to print out file doesn't exist, right like that. Otherwise, we're going to say else, that means we found the file. I'm going to say return the data frame. Now I can go get df from CSV, copy that, jump down here to our test area, bounce inside of here, and we're going to say get df from CSV, and we're going to specifically ask for Amazon, and I'm going to save this. And this is a data frame, remember, of all of our information. This is a data frame. This is what it actually looks like, okay? So I'm going to get all that information, and then I'll display it on the screen. And you can see that there it is. It's all displayed. All right, so we're able to grab data, save data, and then retrieve data. All useful stuff. Now what I'd like to do is to go and get that information and then also create a new column that's going to have daily return data for every single day. So what am I going to call this? Well, I'm going to call this define add daily return to, and we're going to save it to our data frame. And it's going to be past the data frame and the ticker that we're working with. And we're going to be able to calculate a percentage rate of return for each day to compare our different investments. And how you calculate it is you get the ending price minus the beginning price, and then you're going to divide that by our beginning price, or you could just get the ending price divided by the beginning price minus 1. All right, so let's come in and let's do this. So I'm just going to come in and I'm going to say data frame, and if you look at the data frame down here, I'm going to use adjusted close to make all my calculations, and then create a new column called daily return. So data frame, and if you want to add a new column, you just say daily return like this, and that is going to be equal to, and I just perform the calculation I just showed you. So that is going to be the adjusted close divided by, again, same data frame, and adjusted close like this. But what I want to do is I want to get the previous daily adjusted close. So how do I do that? Well, shift is a function that's going to provide the value from the previous day. And how you do that is you just say shift and 1 like that. And then we subtract 1, just as I showed you in the equation above. Now, if I would want to then come in and save to our CSV file like we did before, I can just come up here and copy this. So I'm just going to select here and grab that and copy it and go and drop it right inside of there. And we have our ticker, which is also passed inside of here. And now after that, we're probably going to want to return our new data frame with our new information. So we'll say return data frame, right like this. Come down here and let's test this out. All right. So I'm just going to come in right here and I'm just going to say add daily return to data frame. And I'm going to pass in the Amazon data frame that we already created, as well as the Amazon ticker. Shift, run it, and now you can see that we have daily return. And the reason why this is not a number is we can't get a daily return from the previous day because we don't have any data. But you can see everything else here and how that works. All right, so we're moving along here. All right, so this time what I want to do is have the user provide a data frame, and then I want to go and get the total return over the defined period of time that they're interested in. So I'm going to create another function, of course. I'm going to call this get return defined time, and we'll get a data frame. And we're also going to get the starting dates and months and all this stuff. So let's go and copy this. So copy that, come down here, paste that inside of there, and then like this. All right. Then after we do that, we need to go and create string representations for our dates. So I'm going to say start is equal to, I'm going to use formatting here with Python. And I'm going to say that I want the starting year and then put a dash inside of there. I'm going to say I want the starting month. Again, another dash. And then I want the starting day that we will be searching for. And that is it. And then I'm going to do roughly the same thing. I'm going to do exactly the same thing for end. So let's just go and copy this guy and bounce down here. And we'll just change this to end instead. And then we just have to change this to E. So let's come in and change this to E for all of these dates. All right, so there we go, got that set. Now what we need to do is I want to be able to grab just the data between the dates provided by the user. To do that, I need to use a mask. And I'm just going to say data frame, and I'm specifically interested in the date column. And here is our data frame. And here is our data frame. You can see that this column is called date. So that's what we'll be working with here. So bounce up here, and we'll say that we are interested in a date that is greater than or equal to whatever the starting date was. And we are also interested in the data frame dates that are going to be less than or equal to the ending period the user provided for us. Then, after we do this, I want to get the mean of the daily returns that we calculated, and then multiply that times the number of days, and that'll give us our final results. So we'll say daily return is equal to df, and use our mask that we just created, and then we are only interested in our daily returns. So daily returns, and we specifically want the mean or average. Now we need to get the total number of days between those dates. Create a data frame called df2, df.location, and use our mask on that. And then we'll go and get days is going to be equal to df2 and shape like that. And that is going to give us our total number of days depending upon the defined date range provided by the user. Now that we have that, we can just go return and days times the daily return. And hope you understand that if we go and get the average daily return and multiply that times the number of days, it's going to provide us with the total return over those days. Okay, hopefully that makes sense. All right, so we got that set. Now we can go and copy this guy, bounce down inside of here, and paste that inside of there. Now what we're specifically going to pass inside is a data frame. And let's just go and let's pass in these dates here. They all look fine. So pass that inside of there. Close that off. And let's go and assign this to a variable called total return. Now let's just make it total return like that. Equal to, bounce down here. And then we could do something like, say, print the total return. I could put the dates inside of there, but that's fine. And there we are. And then total return. And there we go. So we got a 18.8% return on Amazon stock if you bought it in January 1st, 2020 and sold it at the end of 2021. That is very, very true. All right, so good stuff. Now I'm going to show you some really cool things we can do with Matplotlib Finance. So I'm going to call this MPL Finance and plot. So this is going to be a bunch of plots that we're going to get. And what we're going to do, again, we're going to get a ticker. This time we're going to get a chart type
because the user is going to be able to enter multiple different chart types that they'd like displayed. And then I'm also going to go and get the starting as well as the ending periods. So let's paste that inside of there. And there we go. All right, so now we got that. What are we going to do here? Well, I need to create a string representation for those dates. Well, I already did that, so why don't we just copy this and copy it and paste that inside of there. All right, good stuff. Now what I want to do is I want to read data from a CSV file. Well, I already did this also. So here is read from the CSV file, and let's just copy down to that point. Paste that in there as well. And there, it's exactly the same thing, obviously. All right, so after we are able to actually go and download that CSV file, what do I want to do? Well, I need to set the data index as a date time index to use this. So I'm just going to go and get our data frame and index and set it to pandas dot date time index and df and point it to the date column. I then need to define to only use data between the provided dates that we got from our user. So I'm just going to call this df sub equal to df lock and start and end. Okay, after that, there are numerous different charts you can use. So you can use a candlestick chart. So if I go plot, data frame, and df sub for the defined range, and type in candle, we can do that. I'm going to show you just about everything. Another plot we have available to us is a simple plot price change line. And to get that, you just type in line like that. And we have more. You're also going to be able to provide moving average data. And to do that, we're going to go OHLC. And we can define our moving average. You can actually use multiple moving averages, which I'm going to show you here in a second. And there we have the average of the previous 4 observations is how that works. I'm going to show you how to style everything. So I'm just going to call this S and MPF dot make underscore NPF and style and base MPF. This is just providing styling for our chart that we're going to provide. And I kind of like the one that is called Charles. And I'm going to define my font size as well. And let's go and do something like font size and set that for 8 because I think that looks good. All right, what else? Well, we need to pass in the defined style for the whole canvas. So I'm going to say fig is equal to MPF dot figure. This is basically the whole entire chart that surrounds the plots and everything. And the size that I want it to take up, I think that 12 and 8 look good. And then we pass in our style, which we just defined, which is S. That's the Charles and the font size 8 that we just have there. Okay. Well, we're then going to this time display a whole bunch of different subplots. So what I want to do is I want to have candlestick subplot, I want to have a volume subplot, as well as moving averages and all this stuff. All right? So to do that, I'm going to say AX is equal to and fig dot add subplot. So subplot. And I'm going to mark this as 2, 1, 2, and I'm going to have this be share x equal to AX. I'm also going to want to add another subplot, like I said, for volume, and I'm going to call this AV equal to fig add subplot and 2, 1, 2 also, and I'm going to say share x equal to AX, which is our candlestick plot. And then what we can do is we can say MPF plot, and we're doing the smaller version of our data frame that was defined. And then we can also have the user pass inside of here, chart type, if you want to use any of the other ones that I referred to above. And I said I was going to be able to use multiple moving averages. Well, I'm going to use 3, 5, and 7. Put parentheses around these guys right here. There we are. And then I just need to reference our different subplots that we have in here. And I'm going to say show non-trading, and I'm going to mark that as true also. Go get that guy. And then we can go and plug this information, and you can see how cool these plots look. Come down into the test functions area, and I'm going to pass inside of here Amazon. So Amazon. And I'm going to use our default we have here, OHLC, as I demonstrated a second ago. And then I'm also just going to throw in, do the same period of time. So let's copy this, paste that right like that, and run it. And there you can see is our plots. You can see the different plots that we made. Remember, we did multiple different plots. There they are, there they are, there they are. There's moving averages. And you can also see here the volume. And there's blocks inside of here, and that just means those are holidays and weekends. And there you go. And you can play around with the different styling and the DPI and so forth to get a more specific, cleaner look. But whatever. Okay, so I think that's good stuff. There we are. Always something to play with. Now I'm going to show you how to create another price plot that is not going to be using Matplotlib Finance. And I'm just going to call this price plot. And it's going to get much of the same information that we got previously. It's not going to have the chart type, however. So let's go and get this. And let's paste this inside of here and then just get rid of the chart type. There we are. And what are we going to do? Well, we're going to do a lot of the same stuff. So let's just go and copy this and copy all of that. I already explained what all this stuff does. And there's that. I'm going to also need to set my date index as a date time index. So that is also going to be needed. I'm also going to need to define the start and create a sub variation of my data frame. So let's just copy that also. Paste that right there. Now things are going to change a little bit here. I need to convert this into a NumPy array. So I'm going to call this data frame and NumPy to note that it's a NumPy array. Equal to, and then you just say df and sub and to NumPy. Now it's a NumPy array, and we can work with it in different ways. Now what I want to do here is I want to get the adjusted close data. And do I still have that showing up down here? Well, you'll just have to trust me. It is in the 5th column. So how I get that is I go NP, and I'm going to call this adjusted close is equal to, and df NumPy and colon and 5 is specifically what we're looking for. And then I want to get the date from the first cell that we have. So that is going to be date array is what I'm going to call this, is equal to df and NumPy and colon and comma and 1. All right, so that's how we are able to go and get specific information from those NumPy arrays. Okay, so now it's time to plot. So I need to define the area that's taken up by my plot. I'm going to say figure is equal to plot and figure. And I'm going to define my figure size to be equal to 12 and 8. Just looks good to me. You can play around with that, see what it looks like. And I said you can increase the DPI. I'm going to increase this to 100. And I'm also going to do some padding and such. And how you can do this is you can say axes is equal to fig dot add axes, and I'm going to say 0, 0, 1, and 1. All right, and I like the way that looks. Okay, so now I need to define, I'm going to show you just a couple different things. Let's say that you would want to come in and you would like to define the line color of your plot. How you do that is you go axes and plot, and I'll say date array, and we're going to print out also this information. The date array is on the x-axis, and the adjusted close data is going to be on the y-axis. And I'm also going to say that I want my color to be navy. I don't know, just picking that because why not? Okay, so another thing you can do is, let's say you want to define the tick marks across the bottom, which are going to be where your dates are. Might be something you would like to play with. So I'm going to go axes, and you can define the maximum number of dates that are shown, and it's going to automatically go and just pick dates for you. So I'm going to set major locator like this, and you say plot and max n locator. And let's say that I want 8 different dates across the x-axis. And let's do a couple more things. Let's say we want to also add a grid. So how you do that is you can say axes dot grid and mark this as true. And let's go and play around with our colors and opacity. So I'm going to set this to 0.6. We can also define our dashes and what they look like. And I'm going to say that I want it to be 5 points. And then I want, this is going to actually represent 5 1-point dashes. And then I want them to be separated by 2 point spaces. And then I'll say 1 and 2 like this. And now just to do one more thing, let's say we also want to change the background color for our plot. So you're learning how to do just about everything. Well, that is face color, and I am going to just go something like, this can be any hexadecimal color code, BD7, like that. All right, and there we are. And now we can go and test price plot. So let's copy it. Come down inside of here. There we are. And I went and commented that out so it doesn't display that. Paste that there. And I'm just going to go and copy this whole entire thing that we have right here. So copy, paste this inside of here, get rid of the chart type that was for Matplotlib Finance. Throw that right there. Run it. And you're going to see that we get a nice chart of Amazon's stock price over the course of 2020 right there. And you can also see how the dates are divided up. All right, so that's how you make a custom plot and then style your plots on a pretty extreme level. Now what I'd like to do is show you how to download multiple stocks, because we want to be able to analyze different stocks depending upon other ones. So I'm going to go define, and I'm going to call this download multiple stocks like that. And we are going to have to define the period of time in which we want to get this stock information. So we're going to get this and then paste this inside of here. And then we're going to pass in an array of tickers that we will look up. Well, you always have to put your arrays at the end of your parameter list for your function. So there's that. And then all we need to do is just say for x in args like that, and then save the CSV from Yahoo, which is this guy. So save to, where is it? Save to CSV from Yahoo. So let's grab this, copy it, come down inside of here and paste that there. And then we are going to pass in, this is going to be our ticker, and then we are going to pass inside of here all of our date information. So there's that, and copy it and paste it inside of there, and there you go. That is all you need to do to be able to download multiple stocks from an array. So we're going to come down here and we'll test it. So I am going to go and create, let's say we want to analyze all the FANG stocks. I'm going to create a list here called tickers, and I'm going to have Facebook inside of here, and we already have Amazon, so we don't need to do that. Let's go and get Apple, and let's go and get Netflix, and let's go and get Google. All right, so we have all those, and then we would like to download all of them and put them onto our machine for further analysis. So let's go download multiple stocks. This guy right here. Bounce down inside of here, paste that inside of there. There we are. And we want to pass in, let's just do the same thing, the same date period. So copy and paste that there. And then we will end this with star and tickers. And that is going to give us all our stock data. And if we look in our files, guess what? We have it all saved as CSV files. So very cool stuff. And now what we're going to be able to do is to merge our data frames, and we're going to use the adjusted close, and then we're going to do plots for multiple different stocks so that we can compare the different returns from all of those stocks. So what we want to do is we want to merge multiple stocks in one data frame using their shared column name, which in this situation is going to be the adjusted close price. So what am I going to call this? Let's call this merge data frame by column name, and we are going to get the column name, which I said is going to be the adjusted close. And then I'm going to go and, of course, get this stuff for the period of time in which we are going to be working with this stuff. And also, we're going to get the arguments. So let's copy that and paste that inside of there. There we go. Got all that. Now, what we need to do is I'm going to create a data frame here, and PD and data frame, right like that. I am going to go and get the start and ending periods here and convert them into a string. So let's copy that and let's paste that there. Then I'm going to cycle through for X in and args. We can change this to tickers. Let's do that so that it's a little bit easier to understand what's going on. So tickers like that. And then I'm going to say mult df x is going to be equal to, and go and read this data. So data reader and x, and we're getting it from Yahoo, and pass in the start and the ending period, and then follow that up with the column name, which I said is going to be adjusted close. Then after we do that for all of them, we will return this new data frame that will just have the adjusted close data for all of those stocks. All right, so wow, pretty awesome. So let's come down here. Actually, before we even do that, let's just come in here and go and calculate the changing values of these investments. So I'm going to call this plot return multiple stocks and investment, and that's going to be the initial investment that they put in, and then we're going to pass in our stock data frame. So what we're going to do is we're going to see in one plot the return on investment for each of the individual securities over the course of 1 year. How you do this is, again, we're going to go stock data frame divided by the stock data frame and iLock like this, and 0 times the initial investment amount. And what I want to do is plot it on the screen. So I'm going to go figure size, and let's increase this to 15 by 6, because there's so much data that's going to be displayed. There we are. Come down here. First thing we want to do is we're going to go and we have our tickers here. So let's just copy this and let's go and not go and re-download that stock information. And we'll go tickers. And what I want to do is I want to put Amazon in this list also. So I'm going to say Amazon like this and come down here. And I'm going to say create multiple data frame is equal to merge by column name, which is what we created up here. So this is merge df by column name. Call that guy and just paste it right inside of there. And we said we were interested in the adjusted closing price. And again, we're going to have the same time period, all of 2020. So grab that, paste that there. And then let's also put tickers inside of it. So there we are, and tickers. There we go. And what else do we want to do? Well, I am going to plot all this information out. So I'm going to say plot, return, multiple, stocks. And I said initial investment. Let's say we put $100 down in each of these individual stocks and then pass in the data frame with all the data. Run it. It's going, downloading all that. Oops, got an error. Fig size is not defined. Oh, I see what I did. And just come up here and just put an equal sign in there. There we are. Come back down again. And if you come down, you can see exactly how much money you would have if you invested $100 in each of these individual securities over the course of 1 year. All right? Pretty good stuff. Now let's talk about standard deviation. Okay, so I'm sure you're well aware that risk is a measure of the variability of the return, like how much it goes up and down as it is providing a return. Well, there's different ways of measuring it. We have variance and standard deviation, which they are basically numbers that tell us how risky a security is. Variance is the measure of how spread out a data set is. And you can see here exactly how it is calculated. Now, let's just work through some numbers. So let's say we have 3 annual returns of 23%, -8, and 15. Well, the mean return for that is 10%. And how you would find it is you just take each of these individual securities and we would go and sum them up. This is the sum sign if you don't know. So we're going to sum all those up after we go and get our square. And then after we do that, we will divide them by 1 less the number of items, which provides us with our variance value of 2.59. Now, standard deviation is a measure of the amount of variation within a set of values. And of course, just like with variance, a low standard deviation indicates that the values tend to be close to the mean. So they're not whipping all over the place as they provide you with a return and getting you scared. And how you get the standard deviation is you just find the square root of our variance value. All right. So what I want to do here is I want to pass multiple different stocks with their adjusted close values. And I want to get both their mean and their standard deviation and another value, which is actually even better yet, called the coefficient of variation. So let's come up here. What are we going to do here? All right. So what I want to do here first is I want to create a function that is going to get the stocks ticker. It's going to display that, the mean and the standard deviation, and then also the coefficient of variation. So let's go and get, let's call this, get stock, mean, and a standard deviation. It's going to be passed the stock data frame that we have been working with, multiple different stocks, and ticker. And it is going to return the stock, and we'll call whatever the ticker is also inside of here. It's going to return the mean of that. That's just how easy it is to get that. And it is also going to return, for each of the tickers, it's also going to return the standard deviation. All right, so I got that and this, and let's go and throw in another function. This one is going to output that information, and it's also going to work with multiple stocks. So I'm going to call this get mult stock mean and standard deviation, and it is going to be passed just the data frame, and it's going to cycle through all that information. So stock in the stock data frame like this, and we are going to get our mean and our standard deviation by calling get stock mean and standard deviation right here. Paste that inside of there. Pass in our data frame and our stock ticker. And then let's also get the covariance of variation, or coefficient of variation, I mean, which is just going to be the standard deviation divided by the mean. And the reason why we're going to get that, you'll see here in a second. So let's go like this, and then I just want to print out all of this information. So the stock ticker, and I'm going to provide 4 spaces to fit in the stock ticker. Then I'm going to have the mean, and it's going to be a float. I want it to take up 7 spaces, 2 decimal places, and it's a float, like I said. We are also going to get the standard deviation, and we are going to have it be 2 and 2 decimal places, and it's also a float. And what else? Well, we'll go format, and we are going to get the stock, and we are going to get the mean, and we will get the standard deviation. I'll put all that on the screen. Whoops, didn't mean to do that. And then we will print the coefficient of variation. So we'll say print and coefficient of variation, and let's just have a new line after that to separate all of this information. So format, coefficient of variation, there we are, and looks good. Come down inside of here, and let's go and call those. So I'm just going to go get mult stock mean and standard deviation. Just pass in our multdf. Maybe you want to see what this looks like also. So our data frame with multiple different stocks inside of it, and then multdf like this. And let's run it. Whoops, I accidentally put a period inside of there. Let's get rid of this and put that there like that. Run it again. And there you can see. And let's talk about why we wouldn't just use standard deviation. Well, standard deviation, this is our mean value for our Facebook stock, Amazon, Apple, and so forth and so on. Well, you can see here that the values are dramatically different. Okay, so you have 234, 2,680, and you can see that because of that, the standard deviation varies wildly. However, if we are able to get the mean value and have it then create a new calculation of total risk based off of the differing prices, that's what the coefficient of variation provides. And you can see that, in fact, based off of all this data, the less risky stock is actually Google, or at least it was in 2020. All right, so there you go. Whole bunch of information. I can provide a lot more simulations, pretty much anything you could ever want to learn about. It's up to you guys and the number of views this video gets. And like always, please leave your questions and comments down below. Otherwise, till next time.